exposed to these things all the time, most of the time with not even knowing about it, whereas in the hospital we actually have the advantage of knowing. So MRSA is not as scary to me because I know how to treat it now, and you will too. The number one thing, and I don't know that this is in the book, I didn't read anything about it when I read through it, but two things about MRSA. This will be on the quiz. Number one, and this applies to all. You may see this question, and it may not say anything about MRSA. It might talk about bacterial infections in general. Number one is hand washing, and that's even in the book statistically, the best treatment for prevention of the spread of MRSA is hand washing. Okay, true of all bacterial infections and non-bacterial infections. Number two, when treating MRSA, empirical treatments. If you don't have the luxury of a sensitivity report yet, then this page 17 or page 314, table 17.1 has a list of some great treatments for MRSA, most of which I used actually. Now, what's important is if you can get a sensitivity report, MRSA is not all the same. Some are more resistant to antibiotics than others, okay? But you are going to learn that there are several antibiotics that are typically always successful. Now, be careful. How did we get MRSA? By prescribing antibiotics. MRSA, that species of Staphylococcus aureus, has a high propensity to accept genetic variations from other bacteria. Remember, in bacteria, they don't pass on genes necessarily just by reproducing. They can, for lack of better words, they can hook up with one another. Literally, they attach and transfer the genetic information, and they transfer resistance. So it's as easy as plugging in rather than just waiting for another generation of bacteria. So that's why MRSA is very, very resistant. Now, here's another thing, and this is real world, not test world, but real world. Not all MRSA requires treatment. Okay, think about that. And I'll tell you why later, but I want y'all to think about why first. Okay? In fact, it actually applies to all infections. Okay, that really is about where it stops, where I can tell you, read this, this, and this. From that page on, I've looked over the whole thing, and it is each class of antibiotic. Know what they are, know what they do. My goal is to have no less than one question about each class of antibiotic. What I'm most concerned about is knowing what we're going to treat. Now, I'm going to try to get this link posted for you also. Here's a little reference that I use, and the part that I want you to see is the antibiotic classes by coverage. So, remember from microbiology, in the lab we'd get our little culture, our petri dishes out, and we'd scrape some of the bacteria out and put it on a slide, and then we would gram stain it. So we have gram positive and gram negative staining, and that all has to do with certain glycopeptides in the cell wall. So here's something that's very helpful, is understanding the bacteria you're treating. Now, this is where the antibiotic section for this course can get complicated, because to understand these medications, you really need to understand what you're treating as well. So it's not just the infection, but what's causing it. For example, let's say you have a skin infection. Which antibiotic are you going to use? Well, there are many antibiotics you could actually start with. And here's the breakdown. You can start, number one, you don't have a clue what's going on. You just know there's an infection, so you start with the most broad spectrum that you can, some sort of penicillin or cephalosporin, very broad spectrum. But let's say you've been practicing for a while, you know, hey, I remember that gram-positive organisms are common on the skin, part of the normal flora. That can be opportunistic. So I'm going to choose a gram-positive selection. Or you may say, hey, this is close to this. This is some skin breakdown in a patient who's incontinent at times, wears a brief. So there's a chance that it could be exposed to gram-negative organisms, which many come from the gastrointestinal tract. So I may want to do something that covers for both, or that has a higher gram-negative power. So gram-positive, gram-negative. The most basic thing I can tell you is most gram-positives seem to live on the skin. Most gram-negatives seem to come from the gastrointestinal tract. Now, I said most, and this is not a microbiology lecture, so feel free to read up on your own. Aerobic and anaerobic. So that breaks the classifications down even more. Aerobic, of course, requires oxygen. Probably not going to find those in a sealed environment without oxygen. Those are going to be your anaerobes. So I'll get this link posted for you, this antibiotic overview. It actually has a very good breakdown of the types of coverages. Excuse me. Not only does it talk about gram-positive, gram-negative, anaerobic, atypical selections. And when we're talking about atypicals, a lot of the times I'm thinking of pneumonias. We have a lot of atypical pneumonias around here, like Legionnaire's pneumonia, for example, and I think it's making a comeback, or has, on the news or something like that. But the other thing is cephalosporins. That classification of antibiotics, remember, number one, that chemically they're similar to penicillins. They have the most cross-sensitivity with penicillins. There are other monobactams, for example, are chemically similar to penicillins, but rarely have a cross-sensitivity, because you're going to find people with sensitivities to penicillin, and then they're allergic to this, they're allergic to that, blah, 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 but you've got to treat with something, and then now you know what the organism is, and you've got no choice. So not all things that are penicillin sensitive are penicillin sensitive, but for perfect world examples, anything that's chemically related to penicillin, avoid it when the patient has a penicillin or allergy, okay? That's perfect world situation. Now, the cephalosporins, however, like I said, they've got the highest cross-sensitivity, but when you can use them, they're very good, and they come in 4 generations. I think that we're trying to say there's a 5th generation now. The cephalosporins, and I always get this backwards sometimes, and I have to look back a little bit. The lower in number the generation, like 1 and 2, are more gram positive, whereas the higher number you go, 3 to 4, the more gram negative coverage they provide. Now, they typically all provide some sort of gram positive and gram negative selection, but depending on which end of the generation you're on, they may be more heavily weighted towards one or the other. So, read up on that. Some of them, it's also a matter of what form they come in, IV or oral. Okay, now I know this lecture is probably frustrating because I'm really bouncing around. I'm cramming a lot of stuff in, and I'm throwing stuff at you as it comes to me that I think you really need to know. Yeah, so this, like I said, this just goes through the different classes of medications, know exactly what they do, and do be accountable for at least the prototype drug for each group. That's like the original Okay. For the quiz, if you see a question that so and so has these, whatever the situation is, they will have an infection. I'm not going to say this is an asymptomatic urinary tract infection. Should you really prescribe antibiotics? No, it's going to be, if I talk about a UTI, they've got it. Okay. Or if we're talking about upper respiratory, or not upper, if we're talking about respiratory infections, bronchitis is usually viral and we don't treat it, depending on the situation. COPD, yes, to prevent pneumonia. But if I'm talking about the lungs, it's not going to be some viral, allergic rhinitis or bronchitis that we can't treat. Remember, we're talking about antibiotics and the non-bacterial infections. I'm going to talk about that here in a second. But the question looks like there's an infection, then there is an infection, and we're going to treat it somehow. Or there's going to be a question about how we're treating it, or the nature of the medication, or this patient's also taking this medication like amiodarone. So which of these would you not want to treat pneumonia with? Okay, read that whole chapter front and back. I'm sorry, it is what it is. So the next chapter, 18, excuse me, goes on into the non-bacterial infections. So we're thinking viruses, other microorganisms that are not bacteria, worms, fungi, all these different things. Now, viruses. The thing